Hello, everyone. Thank you so much for joining us for the fifth and last of our 5 webinars in our Looker Toolkit series. My name is Mary Newton, and I'm the Customer Education Manager here at Looker. And today, one of our amazing Senior Professional Services Consultants, Sharon Zhang, will be diving into derived tables. Sharon is one of our most experienced consultants on the professional services team and has worked with some of our most complex implementations. I have just a couple of quick housekeeping items before we get started. First, you should see 2 different windows available within the webinar platform. The one showing now will present slides, and the one called Media Player will show Sharon's demonstration later on in this webinar. Second, there is a Q&A panel within the webinar platform, and you can feel free to use that throughout the webinar for any questions that you have. We will try to address a couple of those live at the end of the session so that everyone can hear those responses. And finally, this webinar is being recorded, so we will share that recording with you after the webinar is over. With that, I will hand things over to Sharon to dive right on into that content.
Thanks, Mare. Hello, everyone. This is the advanced analysis of derived table session. My name is Sharon, and here's a quick little intro. I'm a consultant on the professional services team out in Santa Cruz. I've been with Looker for about 2.5 years, and I've done quite a few customer implementations and helped onboard several of our customers onto the Looker platform. So with that, we'll dive right into the agenda. So kind of talk about why do we care about this topic, right? What are derived tables and why or when should I ever use them? And then I'll kind of talk about different types of derived tables that we have and we'll run you through some walkthroughs of the different types of derived tables. And then we'll end with a little bit of time for questions at the end. All right. So you've been developing inside of Looker, right, for a little while, and you kind of come to the stage where you realize that you've learned how to define explorers, but you come to this point in time where you're questioning whether you can do even more with your explorers and even more with the analysis that you're doing with the model that you're building inside of Looker. So what I mean by this is in your explorers, right, you're defining a bunch of joins, right, whether they're left joins or inner joins of kind of pre-existing views or tables, right, from your database. And at some point in time, right, you might want the flexibility to be able to kind of pre-restructure the data in several different tables, right, from your database, like aggregate data, right? Or you might want to define some more complex query logic rather than just simple joins. You want to do, subqueries within queries, right? So anything right beyond a simple join, you're not really able to do with what exists with join definitions and explorers. So some of this type of analysis that are examples, right, where you oftentimes it'll require some advanced table building, include cohort and retention analysis. Sessionalizing event data, right? So you're looking at event data. I need to pre-aggregate that data to be able to do analysis for the users, right? Where the events are coming from, right? And then the last item, pre-aggregating. So how do I do this then inside of Looker if I can't accomplish this through a simple join? Well, there's something called derived tables. So these are essentially manually written queries, and manually written queries whose result set can be treated as if it were a regular table from your database, or it could be a regular view from your database as well. So if you look on the right-hand side there, this is one example of what a derived table may look like. So you'll recognize the view definitions, right? So we save our derived table definitions inside of a view file as if it were a regular table, but instead of that SQL table name parameter that points us to the physical table, right, or view from your database, what we have in its place is this derived table parameter, and then in there we are writing actual SQL, right? So you'll see an entire select from, some joins, really whatever we want to put that produces a valid query. So this example that you see on the right-hand side is what we call a SQL derived table. So I mentioned earlier that there are actually a couple of different types of derived tables. So this is probably, if you've been exposed to derived tables, right, what you're familiar with, and you kind of recognize this. So SQL derived tables is one type, and the other type that we'll talk about today is a native derived table. So a native derived table essentially leverages the logic in the lookml layer that you've already built out, and the specific part of the lookml that we're reading from for native derived tables are your explore definitions. So we're kind of taking that logic and asking Looker to help us produce the SQL for our derived table. And then the third note on here is that both of these types of derived tables, they can either be ephemeral, meaning they do not actually get written to the database, right? The query that sits within the derived table will get processed in real time as we call out fields, right, in the Explorer from our derived tables. So ephemeral derived tables are essentially, depending on what database you're in, the equivalent of either a create temporary table statement in your database, or they could be a CTE if you're in an MPP database. So that's ephemeral derived tables, and then the other type of derived tables, we can actually physically write them into your database, and that's what we call a persistent derived table, or a PDT for short. So we're not really going to get into the details of how to produce a persistent derived table today, but essentially with a persistent derived table, because you're writing it into your database and you're writing the results of your derived table query right directly into your database at runtime, I as the end user will not have to sit there, right, and wait for the derived table query to produce the results, because the results are already there, right? So oftentimes we create PDTs for performance gains. So the next question you might have is, right, I mentioned, right, there are these two different types of tables, right? And I said that in the SQL derived table, we do have to write SQL. And then in the other version, you actually, in some cases, not all cases, have to write zero SQL at all. Looker will do all of the writing of the SQL for you. So this slide kind of lists out a couple of pros and cons for each of these two types of derived tables. So for a SQL derived table, I think most of us as in lookml developers, right, we're pretty good at writing SQL, very comfortable. So SQL derived tables are extremely easy to produce if you know SQL, right? Because I'm just writing SQL against tables in my database. They're easy to create, and oftentimes, right, we already have kind of common queries that we use, complex queries that we use all the time saved, right? So what I can do there is just pull one of my saved queries, right, and add it into Looker as a derived table, and that whole process is a very short process, right? And then immediately I'll have the results of those of that query inside of Looker, and I'll show you how to do all of this in a little bit here. And then the last pro that I'll call out for a SQL derived table is that if you're doing lots of complex joins where you're joining like subqueries together, right? If you're doing calculations that span across multiple pieces of your query, it's really still very easy to do, right? Because as long as you write out that logic in your query, you just copy and paste it into Looker, and then you can use it. So all of these, I guess, can be viewed as cons for native derived tables, but there are some big pros that you get from using a native derived table. So with native derived tables, because you're not writing custom SQL yourself and you're leveraging what you've already defined inside of Looker, right, we are able to kind of reuse code, lookml code that we've already written. And we know we don't have to maintain this code anymore because I'm just referencing lookml objects, whether it's explorers or dimensions, right, from the views within an explorer. I'm just referencing them in my derived table definition. So if those definitions change for some reason, it'll automatically be reflected across all of my native derived table references. So that's probably the biggest pro that I would call out for a native derived table. And then the other thing that the other thing about native derived tables is that essentially to troubleshoot and for other developers or at your company to understand what you have done to create your query, I think it's much easier to troubleshoot, because the way that you write native derived tables is very standard. There are some standard parameters that you define, and it's easy to read through that code, and it references, again, right, LookML that's been defined in other files, versus a SQL derived table, right? That SQL in there could really be anything, and it doesn't have to follow, SQL best practices. It doesn't have to be an efficient query, right? There's really no gate there as to what you can put inside a SQL derived table. So here, right, we have our choice, and in a little bit, we'll all talk about our recommendation as to which one of these you should try to use in the majority of use cases. So just in general, how do I create a derived table, right? Whether it's a SQL derived table or a native derived table. Well, there's two paths that you can go down to generate these derived table view files. So on the left-hand side here, we see what I've defined as the Explore or SQL Runner flow. But essentially, you're leveraging some aspect of the Looker tool to create, whether you're physically writing the actual SQL or just using an Explorer to build out the query, the SQL, right, for your derived table. You're using some aspect of Looker to generate code and produce a result set. And then Looker will read that result set that you've produced with the query that you've written or that Looker has written, and it will allow you to auto-generate a view file that references all the columns of your result set. So I'll show you an example of what that looks like in a bit here. And then the other end, I do want to call it, so I would say in 99% of use cases, this flow on the left-hand side is the way to go. The other 1%, I would say, is it really depends on what your use case is here, but there is a chance that some people might want to produce these derived table view files programmatically, right? I have to produce a derived table for every single customer at my company. I have 1,000 customers, which means I have to produce 1,000 derived table view files. Am I going to do that manually through this process on the left-hand side? Probably not, right? I may go through that process once, and then I might set up some sort of Git script, right, to programmatically produce those files and make the small changes that are needed to those files and to the queries that are written in those files. The reason that I wouldn't recommend this more programmatic and code-based way of producing derived tables is that there's no check to actually make sure that the SQL that you're defining in the view files that you're producing programmatically actually works, right? And if it doesn't work, then your derived table doesn't work. So our recommendation is that you always want to use either an Explorer, right, or the SQL Runner to produce your derived tables. So let's talk about how to create each of our two different types of derived tables. The first one that we'll talk about is a SQL derived table, the one that has a flatter, easier learning curve here. So what we're going to do is essentially write our SQL query in this tool inside of Looker called SQL Runner. And then there are a couple buttons that you push and some names that you'll give that file that you're creating. But pushing that button will help you auto-generate this view file, right, that has the derived table SQL definition inside of it. And then Looker will produce one dimension for every column in the result set of your SQL derived table. And then there's some amount of cleanup that we'll do to that view file, and then we can reference it in a join in an existing Explorer, or we can define a new Explorer, right, and expose this derived table, and we're exposing the results, right, of this derived table. to the front end users. So I think I'm going to now switch over to a Looker instance. So I think you'll need to toggle between your media players. So one sec here while I share my screen here. And then I'm going to pause for like 5 seconds to give everyone's computer a chance to catch up to what's shown. So now you should be seeing a slide that says example data set. So we're just really going to quickly talk about the sample data set that we're going to be using. So hopefully everyone can see this now. So the data set that we're working with lives in a Redshift database, and it is an e-commerce data set, and we have 3 simple tables that we're going to use. We have a users table, an orders table, and an order items table. So, right, essentially users are making purchases that are recorded through orders, right, and orders have multiple order items. So let's switch over to a Looker instance here, right? So I've already modeled out an Explore that has all 3 tables joined together. So that's what it looks like. And then we have our Explore built out, right? We have all the fields available. So this is pretty standard. And this is kind of like the point that I was talking about where you're like, okay, well, that's great. I've joined all my tables together. What more can I do, right? Can I do some more advanced analysis with the data that I have? So let's see an example of a question that we can answer that will require the use of a derived table. So here, the question that I'm going to pose here is, which 10 states in the US have the highest average user lifetime value and average user lifetime order count for their users? And then the little bonus down here just says, what are the first and last order dates for each user? So if we break down this question, you begin to see kind of 2 levels of aggregation needed for the analysis that it's asking for. So what are those 2 levels? Well, if we just take this one metric here, for example, right? It's called average user lifetime value. So what does that really mean? Well, it's asking me to, at the state level, right? It's asking me to take an average of all the users' like independent lifetime values, right? And that's the metric that I'm trying to display. So taking the average of the sum of kind of user spend, that's 2 levels of aggregation that normally cannot be done within the same view file, essentially. So you can't have a measure that tries to aggregate another aggregated measure. So what that translates to, right, inside of SQL is if I tried to take, the average of a sum of a field, right, that's not a valid SQL query, and you can't do it inside of SQL, which means you can't do it inside of Looker. So the way that we're going to do this is through a derived table. So things like user lifetime value and user lifetime order count, and also, right, user first order date and user last order date, those are all kind of what I would consider facts about a user. And I'm actually going to create a user fact table that kind of pre-aggregates up all 4 of those pieces of information, right, at the user level first. And then I'll have that table, which we'll get more into this, but we're essentially dimensionalizing these would-be measures into dimensions, right? And then from there, I can then take the average, right, of all the user lifetime values from a certain state, and then I can accomplish this analysis. So without further further explanation in here, we're just going to hop in and I'll walk you through the example, and hopefully if you're a little bit confused, I can help you clarify that confusion. So where do we begin? Well, I said that we want to produce a user fact table, right, from the information that we have from our pre-existing tables in the database. So what I'm going to do is drop down the Develop tab and open up this tool called SQL Runner. And inside of SQL Runner, you'll just want to make sure that you are querying the correct connection and schema. So I'm already on the correct connection, right? We're in our Redshift database. So here, what I'm going to start doing is I'm going to start writing, actually, you know what, let me show you the data first before I write anything. So here, right, I suspect that we'll need, so we're looking for user information. I want to know kind of how many orders they had and how much they've spent essentially on those orders. So here, I'm going to do a select 10 on the orders table just to see what fields we have, right? If I'm not already familiar, this SQL Runner tool is really great for data exploration. So here, okay, that's fine. It looks like I have some information about the order ID and which user ordered that order. And then let's take a quick look at our order items table. In the order items table, right, I have an order items ID field. I have an order ID field. I also have a user ID field. And then I see sale price, which is actually the field that I'll need to produce their lifetime value. So it looks like this order items table actually has all the information that I need to produce a user fact table. So I'm just going to use this table, and we'll kind of begin to write our query that will give us user facts. So it's a user table. So I think we'll definitely need to bring in this user ID field. So what are some other fields that we need to compute? Well, I need to get a count of orders essentially. So I see this order ID field, and if I get the distinct count of that, that will be the user's life. And to produce their lifetime value, we'll just take a sum of the sale price field. We'll use that as our proxy for lifetime user lifetime value. That's fine. And then those two bonus questions, right? We want to understand for each user what was the first order date and the last order date. So some additional functions here. So I actually have a created at field that I can use here. Actually, because I need to know the minimum date for a minimum date, right? Create at date for at the order level. I'm actually going to change the query that I'm writing to start from the orders table, so I can pull the created at field from that table instead. So let's see. So we're going to take from public orders. We're going to do the left join in the order items table on orders dot ID is equal to order items dot order ID. Okay, so great. And then now we'll kind of finish. So now it's going to be orders dot, oops, there's a created at as first order. I'm going to omit the word date here, and you'll see why when I create the view file. And then the other one's the same thing, except it's a max. Oops, as last order. And then we'll need to add a little group by. So actually, sorry, 1 second. Let me just explicitly, yeah, we can take from orders. And then just order items. I'm not going to change it. Okay, order items. I'm just explicitly scoping my fields, so there's no confusion. And then we'll just group by 1, run. So once you, oops, I spelled something wrong. Once you have completed your query, you'll need to run that query in here, which is why I'm keeping this limit so the display of the data loads quickly. And the reason that we force you to run this is because Looker is verifying that the SQL that you have written or pasted here, right? You didn't have to write it in here. You can write it in your wherever, or just pull in an existing query. Looker needs to make sure that it actually runs, right? Because if it doesn't run, Looker will have no idea of what columns exist in that result set, right, to be able to help you produce your view file. So after we verified that the query runs, we're going to add it to a project. So gear button, right, add to project, click on it, and then we'll need to make sure we're putting it in the correct project. So my project's called DT Webinar. I'll give it a view name, so we'll just call this one user order facts. And then I'm going to hit add. And then what that does is it will now produce a view file for me for my derived table. So you'll see dimensions defined for every single column in my result set. So there's some amount of cleanup that we'll need to do. Just a few things that I'll call out in here is if you put any sort of limits on your query to make it run or run quicker, you'll need to remove those limits, right? So my query looks good now. There's a measure in here called count that's counting up essentially users, right, in this table, and I don't actually need that, so I'm going to delete it. I already have a user count field in my actual users table, so no need for that. And then I need to define a primary key in this view file to make sure that if I produce any measures in here that they're computed correctly. So the user IDs are our primary key. And then just going through, making sure that everything looks good. And then right on your dimension group, you may want to put in some time frames. So on dimension groups, I'm just going to put 2 as an example. For dimension groups, the reason that I omitted the word date from it is that Looker will actually automatically append the word date to any dimension group in the UI. So there's really no need for saying date again in here. So once you have, so now, right, we've successfully produced a derived table. So this derived table is called user order facts. And now in my model file, anywhere, I'm able to reference that derived table. So now I can actually join my derived table as if it were a regular view file, right, in a join in an Explorer. So here, right, in our users table, I can join in user order facts, and then I can, I'm just putting in all the same parameters that I normally put into my joins, right? I'm doing a left outer join. I can join this directly onto the users table. So users.id is equal to user order facts user ID, and then my relationship here is 1-to-1, as both user IDs are primary keys in their corresponding tables. And then we'll hit save here. So really what I've joined in here, right, this is really like the ordering user order facts table, right? This user order facts table doesn't have any information for users who didn't produce any orders, because I created it based off of the orders table. So that's why I'm doing a left outer join here instead of an inner join. But anyway, now that I have this, I'm going to go into my users explorer where I've just joined in that table, and you'll see on the left-hand side right now I have all the fields that are associated with my my user order fact table. So with that, we don't need to dig into the data here, but essentially I now have the information that I need to produce these 2 calculations. So actually, I'm going to create these so we can kind of see. So now I have the user total lifetime order count and lifetime value. So now that those are dimensions, I can actually create measures called, I'll just do it for one as the example, because I think you get the, so now it's right, I have average user lifetime value, and then the type of this is going to be an average. So I'm doing a layer of aggregation here, and then the column that I want to take the average of is lifetime. So now when I save this, and we'll give this page, the Explore page, a quick refresh, right now I see this measure. So now when I bring in state, and where's state? Here we go. State, right? I can bring in average user lifetime value, and I'm able to produce that graph from the question here. So that's an example on SQL derived tables, right? A super simple example, right? But it's really SQL derived tables are kind of unbound. You can do as many joins or put whatever logic, as long as it works inside of SQL, it'll work here. So this page just has the solution on it. So now we kind of turn our attention to native derived tables. So this is the type of derived table that is more sustainable, I think, in the long run. So this is actually our recommendation, is that whenever possible, when you don't have kind of like, more than 3 or 4 levels of nested aggregations or nested subqueries and queries within a piece of SQL that you want to add as a derived table, the recommendation is to use a native derived table because they're very low maintenance after you produce them, but the production of them is not always super simple. So I'll kind of show you what that means, but essentially the path to produce one of these is a little bit different. So what we need to do is identify and explore that will give us the fields or the columns that we need for this native derived table. And if an explorer does not have all of the fields, we just bring in as many as we can, and there's some SQL that will write into the derived table ourselves to produce the fields that are kind of missing, and you'll understand what that means in a bit here. So I'm actually just going to do the walkthrough for you, but essentially you're building out the query in Explore, and then there's a couple of buttons again that you press that will auto-generate LookML for you, and then we'll create a new view file, paste that LookML in, and then you have your new native derived table view file that then again you can join into your Explorers, define a new Explorer with it. So with that, here's an example of the analysis that we're going to try to do with our native derived table example. So this says, in which number order in a customer's lifetime are they spending the most money? So what does that really mean, right? As a customer, right, in my entire lifetime, I can make a number of different purchases, right? We want to assign a number based on like when that purchase was made. So in my first order, I spent $100. In my second order, I spent $500. Third order, $10, right, etc. So I kind of want to figure out for every single user and in each of their orders that they've made, what the sequence number of that order was, and then I want to also know the amount that was spent on that order. And then from there, I'll have the fields that I'll need to produce this analysis that you see below, that essentially what we're looking at is for my entire customer base, which number order are they, right? Are they spending the most money? So we don't want to look at, these are kind of outliers all the way on the right, but if we look here, right, my company seems pretty successful because what it seems like is the average order size is increasing as people order more and more, right? So maybe like this kind of information will help drive my marketing spend or my marketing tactics. But anyway, how do we produce this table? Oops, sorry, nope, don't look at the answers. How do we produce this table that will allow us to do this kind of analysis? So what we're going to do is actually, I'm going to clear this out, and then we're going to look in this Users Explorer that we already have, and it does have some of the fields that we need to do this type of analysis. So let's just bring in the fields that are already available, and then we'll talk about what's still missing and what we need to produce ourselves. So essentially, I'm right, earlier I mentioned I need to know for each user, which means I need to bring in user ID for each user and each of their orders, what the sequence number is. I don't have a field that tells me what the sequence number is, but how am I going to figure that out? Well, I'm going to look at the created date, or let's use time instead, the created time of each of those orders. And then additionally, the other thing that I said I wanted, right, was for each order, I need to know how much they spent, so I can create some sort of order, right, of which order for each user they spent the most money on. So from order items, that's where my total sale price measure lives. So I'll have to bring that field in as well. So I brought in all the relevant fields that I'll need to produce the calculations. So I'm going to hit the run button, and then Looker will return a list of results. This is sorted in a weird way so that you see all the users that don't have orders, which is fine. So if you look at this, right, I want users, their orders, time, total price. Great. So this is my basis. Now I'm ready for Looker to produce my native derived table file for me. So here, we'll click on the gear button, and there's an option here that says Get Derived Table LookML. We'll click on this, and then I'm just going to copy everything that's in here, and then head into my project here, right? In the project, I'm going to hit the plus sign next to the add button, and then I'm going to say create view. So I'm creating a brand new view file. So we'll just call this table user facts, because I can't have the same name. So call it user facts, you call it whatever you want. So, and then in user facts, I'm going to take everything that's already in here, delete it, and then paste in what was on my clipboard. So here we'll want to give our view a unique name. It's user facts. I want this name to match the name of my file so it's easy to find. And now you'll see the syntax that's in here. I'm not going to go over all of the syntax that's associated with native derived tables, but I will call out a couple of the most important ones. We'll talk about kind of 3 of the most important ones. The first one, and you don't have to worry about this because it's produced automatically for you, is explore source. This basically is referencing the name of the explorer that I was using to produce this table, right? This is our explorer called users. So that's why it's called users. And then column are exactly what you think they are. These are the fields that represent columns in my native derived table. So I have something called ID. I have another thing called ID. That's already not great, right? Because now I have 2 dimensions that have the same name. So what I'm going to do is add in this parameter to both of them called field. Field will allow me to explicitly reference the view name dot field name of what I want the column to reference. And then what I'm actually able to do is change the name of the column to whatever I want, because it's just a name. So, oops, I spelled that wrong. So the first one we're calling user ID because it's the ID field from the user's view. And then from the orders view, I'm taking the ID field, and that's going to be the order ID. So down here, I'll make the corresponding updates. And then these dimensions are essentially referencing your columns here. So those names will need to match. So here, order ID, right? So if we're examining our columns, right, I'm cleaning up a little bit, right? I have user ID, order ID, created time, and total sale price, which is essentially the equivalent of the price of the order. So now we need to produce our missing columns of data that we need to do that analysis. So how do we do that? Well, since we need to produce them ourselves, we're going to use this parameter called derived column instead of regular columns. So regular columns will just reference like physical dimensions from views within this explorer. Here, we're going to produce a derived column. So inside of our derived column, we can actually write in entire window functions, which is how we would use a window function, right, to get the order sequence, as well as order the orders of each user by total sale price. So we'll kind of build those out as derived columns. So the first one that we'll build out is called order sequence number, right? So for each user, which number order are we looking at? So we name it whatever order sequence number, we can name it whatever we want. And then here in a derived column, you define the SQL parameter, and this is where you're writing in a little bit of SQL. So here we're saying, hey, I want you to essentially rank all of my orders for a particular user. So here's my window function, and I'm going to say that we're going to partition by users because I'm doing it at the partition by user ID, and then we're going to order by order sequence number. So I need to order by the created time. So created time, and it's ascending, which is actually assumed, so I don't need to write that. So now it'll just number it 1, 2, 3, 4, 5, right? It'll number each order for each user based on created time, right? 1, 2, 3, 4, 5. So that's my order sequence number. And then I'm going to create a similar derived column that is essentially, we'll call this order rank by like sale price. Essentially, I want the highest on top. So rank 1 for each user will be the order that produced the highest amount of sales, right? So here, same thing in the SQL, I'll do the same thing. So it's going to be rank over, and then again, we're partitioning by users. right? So we're partitioning by user ID, and then this time I'm ordering by total sale price instead of create time, right? And then I want this, oops, sorry, no, I don't want it, I want it descending. So rank order 1 is kind of the one that we want to look at here. And then we'll hit save here. So now that I've produced these 2 derived columns, I will need to go down into my dimension section and reference those 2 dimensions. So I'm actually just going to do a little bit of copy and pasting. Then we'll define a type on here. And both of these are numbers. And then same thing with this one. We'll have order, rank by sale price, and then the type is also going to be a number. So now from our dimensions, to be able to do that analysis that we want to do, I do need to produce a couple of measures. So what are the measures that I'm going to produce here? Well, one is I do need a count of users in here. So I'm going to say count users, and then I'm going to say type here is just going to be, it's actually a count distinct, right? Because my table is getting fanned out by order IDs over here, right? So I'm counting the distinct on the field called user ID. And then the next measure that I'm going to produce, so I need to create that measure called average order size, or average order price, we can call it average order price, to indicate that it's a price. So here, actually, I'm going to use the number type here, and you'll see why, because I'm actually going to type out the function here in the SQL parameter. So here, I'm going to take the sum. So this is actual SQL that I'm writing, the sum of total sale price. And I'm going to divide it by the count. And then the count I actually produced as a measure here. So the number of users, right? So that'll give me the average order price. And then the only thing is that when you're doing division in a SQL function, you'll want to protect against division by 0. So I'm adding in this null if function that will protect me against that. And then I'm adding an additional parameter here just for nice formatting of USD and hitting save. So these are the 2 measures that I'm producing here. And then let's just go see, because I wrote the SQL myself, right? I'll want to do some testing. So here, just for testing, I'm going to define my Explorer user facts here and hit save. And then I'm going to be able to open up my Explorer user facts, which is just this table because I'm just QAing. So from here, let's try to do that analysis that this question was asking for. So in which number order in a customer's lifetime are they spending the most money? So, well, if we look at order rank by sale price, we basically only want to look at the orders that produce the highest sale price. So here, I just want where that rank equals 1. We're only looking at those orders. And then we're looking at users and then their average order price. Oops, sorry, not users. What was the question over here? Oh, just based on based on order sequence number. So not we're looking at, so it's order sequence is the number order in which this occurred, right? So, and then I'm seeing what the average order price was across all the users that fell into each of these buckets. So I'm going to hit run, and hopefully we don't have any SQL errors here. Uh-oh. We do have a SQL error, so we'll just need to fix that error. So in terms of just like a quick note on troubleshooting here is, right, this error says, hey, position, I don't know. I don't really know what it says. You can go into the SQL part of this and open up your query in the SQL runner, and hopefully this will give us a little bit of a better, it kind of tells you where your order occurred. So somewhere around this region, but don't really want to use up all of our time on that. So I'm actually just gonna, I'm just gonna paste over my code that I've already written. But essentially you'll need to kind of troubleshoot, you'll need to troubleshoot your query and make sure that it's working. And then let me just place these here. Delete this one. And then hopefully we get this to work. Let's see if this error will go away. That like an extra as somewhere. That's weird.
Hey Sharon, there's been some help from the audience. There may be a closing parenthesis issue
That's
on the
missing.
average.
Oh, did I not close this? Oh, I already pasted over it, so here we go. Okay, and bring in average order size. Sorry guys, that was my bad, yeah. Missing parenthesis. All right, here we go. And then now I'm building the visualization, right? So I can kind of see, okay, right, as people order more and more, right? Like most people probably made one order and stopped ordering. We can't really see that, right? So we might bring in, count of users to see that the sample size is big enough, but removing that from the equation altogether, we can kind of see, we'll just look at the first few orders. We can see like a general upward slope, which is probably means great things for my business, right? So that kind of accomplishes the analysis that we were hoping to achieve with this question that was posed here. So this is an example of a native derived table, right, where we've added in some window functions through the use of derived columns. So one thing about native derived tables that I want to call out here is that if you don't already have the Explorer built out to be able to produce the columns that are needed, right, for the analysis that you're trying to do, maybe it makes that you might have to build out that Explorer, or if you'll never use that Explorer in any other use case, that might be the case to use a SQL derived table instead, right, to define that logic. So just like kind of another note on when you should kind of not use a native derived table. But if that's not the case and you already have Explorers built out like I did, right, the Users Explorer, I use that. Do use native derived tables, because now all of this information, the definition of these fields, right, if now I change how total sale price is defined, right, I don't need to come in here and update the logic for that, right? I'm not writing that logic into this file specifically. So that's native derived tables for you. And then let me toggle back to the slides here. The answers are on that page. And then in summary, right, you're using derived tables to restructure your data and to create more complex levels of analysis using SQL. And then so for as a takeaway for you guys, right, go back to your own instance and try to implement a native derived table and take a look at those kind of new parameter names that we introduced you to today. And then there are several patterns that are available online. A couple that I'll call out are called cohort analysis, and there's one on retention analysis that's really good. Try to implement a couple of those, right? And maybe you'll be able to kind of translate those into a native derived table that you build into your Looker instance. And with that, let's open it up for questions.
Yeah, so we've actually had a couple and they were related. So I'm going to pose you a bit of a compound question here. In terms of performance, are derived tables less performant than regular explorers? And if not, why don't we write all views as derived tables?
Yeah, so that's an interesting question. So from a performance standpoint, the answer is not necessarily yes or no. It really depends how you're defining your explorers, right? If you're using explorers, and how you're defining the SQL that you're writing. So could be yes, could be no. You could be writing really efficient SQL that the explorer that's been defined is not writing, but there's usually a way to make it efficient. So if done right, the answer would be no. The derived tables are not more efficient than Explore queries. And then why wouldn't we want to just convert everything into derived tables, right? Because I already know SQL. I have all these SQL queries saved, right? That could be a case for some of us, right? I don't really want to spend this time building out all these explorers when I know that I have this option to just paste in some queries and generate some derived tables. Well, the reason for that is if you're pasting in a large block of code, a large block of SQL code, that just kind of sits there. It's a static block of code, right? There's no flexibility. So when the user asks to filter things, right, your query is not building or adjusting dynamically, and it's not the most efficient that it could be probably, right? So with explores though, right, the query is kind of building on the fly, and we're allowing for adjustments based on what the user is inputting or asking for. And then the other point on that is your explorers are completely reusable, right? Users A and B can come in and ask all kinds of different questions that a single explorer can fuel, right, an answer for them. Versus if you create all these kind of static derived tables, right, they're all custom, so they each are set out to answer, certain questions. And if someone adjusts their question a certain way, right, you might have to produce another derived table. So the maintenance of derived tables is not as easy as maintaining kind of more flexible explorers.
Great. Thanks, Sharon. A couple more just came in. These will be a little quicker, I think. So the first one will be a great one for everyone to know. It's where can the cohort and retention analysis templates be found if you want to do some of that and maybe have a starting point from things that Lookers have developed?
Yeah, great question. If you Google Looker retention analysis or cohort analysis, whatever analysis you might think that you want to do, you'll be brought to a link that will give you access to the blocks, what we call blocks, which is essentially blocks of code that you can tweak a little bit and then add into your instance. So here I did a Google search for Looker retention analysis. This is the block that has the pre-written code for it. So I'll just need to modify it, right, for my own data table references and column references here. So that's what it looks like here. But just like, and then also in general, it's if you forget that, discourse.looker.com is where you can find all kinds of information and pre-written analysis patterns that you can leverage, whether they have to do with derived tables or not. So discourse.looker.com, you can also go there and search for these types of blocks or analytic blocks.
Awesome. Another quick one for you. Can you add SQL triggers to native derived tables?
Great question. So absolutely, you can, and you add them in the same way as if you would. So really what we want to use is something called a data group trigger, but yeah, you can. So the same way that you would to a regular derived table. So here I can reference a data group trigger that triggers, a rebuild of my table at midnight. I just have to make sure that I've defined that data group. Yes.
Fantastic. And I have one more for you before we close the webinar. Are derived tables recalculated every time you launch a look?
Good question. Yes, they are. So a regular derived table or an ephemeral derived table is run every single time someone runs a query that is asking for a field from that derived table. So here, right, if we don't persist this table, yes, it will run every single time. So when you have tables that take quite a long time to run, you will want to think about persisting those derived tables so that we're not just running the same query as part of a query, right, over and over and over again.
Perfect. Well, that about wraps us up for today. Thank you all so much for joining. If any questions come through that we didn't get a chance to answer live, we will follow up with you after the webinar, so feel free to keep sending any if you have them in these last minutes. This also is our last webinar of this series, but we will be taking some of these sessions with us on Join the Tour. So be on the lookout for tour stops in cities near you because we hope to see you there. Have a great day, everybody.